Welcome, everybody. First of all, I'd like to ask that we hold our questions till the end so that we can get those into the mic and also have them for the VC and the video. Our speaker today is Edra Zigmuntovic. He's the lead developer on Merb, and he's also a co-founder of EngineYard. He is also of a book called Deploying Rails Applications, which I'm sure you're aware of, and also he's contributed to open source projects like Merb and Rubinius. So please welcome Ezra Zigmuntovic.
Hi, everybody. My name is Ezra Zigmuntovic. Like you said, I have a little company called EngineYard. We've kind of become a two-headed company at this point. We started off to be like the rack space for Rails, build a fully managed clustered hosting company specifically targeted for Ruby and Rails applications. And that's been a big success. And we kind of have another branch of the company doing like rack space or Red Hat for Ruby. So building a complete stack, including our Linux distribution, a collection of open source software, and we have a number of open source projects, Rubinius, Merb, Vertebra, a bunch of other stuff going on to kind of build this full stack system. So yeah, that's a little bit about what EngineYard does. Today I'm going to talk about Merb and Rubinius a little bit, and we'll start off with Merb. Merb is a Ruby web framework. Takes a lot of inspiration from Rails, as well as a number of Python frameworks and Java frameworks, and tries to conglomerate them into what we think is a very nice Ruby framework. Merb kind of started way back in September of 2006 as a simple hack to do file uploads outside of a Rails application. And this is actually the whole first version of Merb. Fits in one pasty. And it kind of grew from there. It just was a fun project to work on in the evenings and weekends. And as it kind of grew up and people started using it, I kind of just was like, oh, well, we can really build a full framework that can replace Rails with this and learn a lot from Rails' good and bad sides. So that's kind of where Merb was born out of. That was Merb then. Merb now has been split up into a number of different packages. We're relying on Ruby Gems, which is Ruby's built-in package manager, to make Merb very modular. So there's a Merb core, which is the core framework, which is all the HTTP handling and tooling code, basic templating and rendering, the rack stuff, which is like WSGI for Python, and a number of other core features for doing. You could use just Merb core itself to do web servlets and small web services and smaller applications. And then we have a number of other pieces that bolt on top of it to form a full stack. And if you just do a gem install Merb, you'll get what's called Merb stack, which is all of these pieces plus a data mapper ORM and a jQuery JavaScript library, kind of all packaged up into something like you would be familiar with Rails, where it gives you everything out of the box. But we've really focused on making sure every piece is built in its own module so that you can pick and choose exactly what you want. With Rails, you're kind of forced into take it or leave it, and you get this whole kitchen sink, and it's really hard to take pieces out that you don't need or to alter the assumptions of the framework. So we've tried to make sure that we don't go down that same road. Everything's modular. You can pick and choose exactly what you want and not use what you don't need. So you get a much slimmer framework that does exactly what you need rather than the whole kitchen sink. A couple of the core tenets of what makes Merb Merb. It should be fast. There's, no code is faster than no code. So you want to keep, especially in Ruby, the current Ruby implementation is a AST walker. It's not a bytecode compiler or anything like that. So the code gets parsed into an abstract syntax tree, and then the interpreter spends all its time walking around this tree executing code. So the more code you write in Ruby, the bigger your tree is, and the worse the interpreter will perform because it has to walk a bigger tree. So keeping Ruby code as small as possible without obfuscating it is one of the core goals of Merb, to keep everything running fast. And we like to keep the code simple and not do a lot of metaprogramming in the core framework, because I don't feel like that's where it belongs. The core framework should be simple as possible for you to open up and read, and it should be fast. So we've spent a lot of time optimizing the framework to take advantage of all the quirks of Ruby, which there are a lot of quirks, right? And so it can take years to become proficient enough with Ruby to know which kind of operations are expensive and which aren't. And we've developed a pretty extensive benchmarking suite that's in the Merb core repository, where we benchmark every little idiom we come across to come up with the best, fastest way of doing something and apply that to the framework. And so it's a ton of micro optimizations, and some people might say pre-optimizations, but taken as a whole, it really gives us a much faster runtime for building web applications. We spent a lot of time focusing on memory efficiency. One of the big downsides of Rails is, until recently, it's been a single-threaded application server. So the application server can actually only service one request at a time. Other requests will kind of back up and wait in line to be served. So you need to run a bunch of these processes. The big problem is that the processes are going to average about 100 megs of RAM each, and sometimes a little bit less, but a lot of times more, even up to a couple hundred megs each. And that's a lot of overhead for trying to run a web application when each app server uses hundreds of megs and can only serve one request at once. So you end up with these huge infrastructures to support these large websites. And we've seen the pain of that at Engine Yard, hosting all these Rails applications. And we wanted to provide a better way. So with Merb, you can fit about 3 to 5 Merb application processes in 100 megs compared to one Rails process. And each process can serve 2 to 3 times the traffic. So massively reduce your infrastructure costs for running a web application by running on top of Merb. It should be modular. We talked about this a little bit. The whole framework is broken up into pieces that all work well together with each other, or you can self-assemble exactly what you need. So I like to say with Rails, it's like the best framework out there for the 80-20 rule. It'll get you 80% of the way there faster than any other framework, but you'll fight tooth and nail for the additional 20%, because anything it's not meant to do is really hard to do. So as long as you kind of stay on this golden path and don't kind of go outside the norm, it's, nothing's going to beat it for that first 80%. But the first 80% is just that. It's the first 80%. Once people are online, they're running their apps in production, and especially with the way the web is going, with all these different kind of mashups, and you've got different database backends that people are experimenting with that are non-SQL, it becomes harder to get that last 20% done. Merb is built to take you that last 20% of the way. We might not quite be as polished yet for that first 80%. Rails has a lot of helpers and a lot of stuff built in, but all those assumptions really add up, and you pay a cost for them later. So, it might take you a little bit longer to get up and running, but it's going to really stay out of your way much better and allow you to go a lot further with the project, maintenance-wise, and integrating other kind of things that we as the framework authors haven't envisioned you doing yet. We want to be able to support all those kind of things. This is kind of one of the big points. I think Rails was a lot of people's first exposure to Ruby, and it was their first big Ruby project. So there's tons of code in there that uses a lot of metaprogramming just for metaprogramming's sake, it seems like. We try not to do that at all. We try to keep the code in the core as simple as possible. And we want and we encourage people, as they're writing their applications, to explore down into the framework as well. A lot of people end up treating Rails as a black box because it is 80,000 or so lines of code, and it's a little bit hard to step into and figure out what's going on because there's so much advanced Ruby metaprogramming going on inside of there. And I kind of feel like the place for metaprogramming and that kind of stuff is in your own application code. I'd rather have the foundation that you're building on top of be as simple and as easy to understand as possible, so that when you do hit the wall and you need to look inside the framework, you don't get grossed out, and you can get in there and actually do stuff with it. We spend a lot of time focusing on the application server part because I'm a big server geek, so I'm real interested in making these things run efficiently. So we spent a lot of time recently building a master worker kind of process manager into Merb. So you spin it up, you get a master process, and say you're going to run a cluster of 3 processes. It will spawn those processes for you, share as much memory as it can. Ruby's garbage collector is a little bit weird, the way it marks all the objects. You don't get very much savings from fork and copy on write as you would with a better garbage collector. But so one of the big things I've seen that's a real hard workaround in Rails is when you want to deploy new code. You say you've got your 5 or 10 application server processes on 2 or 3 servers. You deploy up your new code, and now you need to restart all these processes, and that can take a significant, couple minutes amount of time. Most people just kind of punt and they put up a maintenance page while they deploy, and you've got a few minutes there where you have to go down in order to to support this new code. What we've done is make it so, say you've got a cluster of 3 processes running your production application, and now you want to do a code redeploy. What we'll do is you do your code redeploy and you run a fast deploy on the Merb server. What it will do is it will spin up 3 new instances, load all your application code, and at the very end, when they try to bind to the port they're supposed to be listening on, they'll try to bind and they'll fail because the old processes are still there. But instead of just crashing, they'll go into a loop saying, hey, can I get this port yet? Can I get this port yet? And then once they're up and running, then you kill the original old processes, and these new ones just take right over. So you effectively get rid of any downtime for doing deploys. So we spent a lot of time working on that. We also integrated Rack fairly heavily into the framework. Rack is like WSGI for Python, WSGI. It's a interface. It's a common interface to many different servers. So it allows us to not have to change Merb code to run on Mongrel or Thin or Ebb or Fusion Passenger or any of these, or JRuby with Glassfish. Any of these things that support Rack can run a Merb application. So you're really portable across where you can run. And one of the big goals here is to stay out of your way and be very flexible. We're not necessarily trying to cater to really beginner Ruby programmers with Merb. We're kind of catering towards a little bit more advanced people who probably have some Rails experiences and have run up against the edges of the framework. So we want to be low maintenance. We want to get out of your way and let you do what you want to do without a lot of ceremony. And if you need to do something that we haven't envisioned, we'll let you do that. We've built into the framework the idea of a public API and a private API and a plugin API. And every method in Merb is documented, whether it's public or private or plugin. And as framework developers, we're free to refactor and change private APIs. And if you use those, it's your own fault if we break them. But we're trying really hard to give public API entry points and hooks for anything people would want to do as far as hooking into the framework with plugins or monitoring tools or anything like that. So rather than the typical, so Rails has encouraged a methodology of using included modules and alias method chain to hook things into the framework. And it's kind of a bad way to go, in my opinion. It obfuscates what's going on. It makes the call stack much deeper, and it makes it much harder to trace through code and see what's actually going on. So we don't allow that in Merb itself. If people are trying to do some kind of plugin and they can't do it without doing some alias method chain dance, then we'll try to add a public API for them with a hook so that they can do that. Because we'd like to see everything going through our public documented API and support people that way. One of the most important things here is that Merb is not constrained by backwards compatibility yet. I mean, we're just about to release a 1.0 version, but a lot of this work I've done here, I originally was trying to do to Rails itself, and there was way too much pushback because, and it's understandable, because there's thousands of people running their applications in production on Rails now, and so changes, big sweeping changes are really hard to get in because it'll break so many applications. And it's also, there's a lot of assumptions built up in this huge code base. So I see Merb as an experimentation ground for Rails. We kind of have a clean slate. We can rebuild things, take what we liked from Rails, leave what we didn't like, take what we like from other frameworks, kind of experiment to see what would we like a Ruby web framework to be like. And we can do that without having all this baggage. So I think that we've built a pretty compelling 1.0 that's in release candidate right now that will be coming out full 1.0 within a few weeks. And that's kind of a stake in the ground. We're not going to break the APIs from here unless we bump a major version number. But a lot of what we do in Merb can easily be applied back to Rails. We're just a little more free to try new things with Merb. We try our best to look at other frameworks and take the best ideas from Django or Pylons, lots of Java frameworks. Of course, we're heavily inspired by Rails. We're built on Rack, which is the same as Python's WSGI. You basically have a class or a proc, a procedure, anything that responds to call and takes an environment, which is basically the hash of CGI headers and stuff you get from any kind of web server. And then we return a tuple of the status, the response status, a hash of headers, and then the response body, what you want to render. And we can use middleware, like we can say use rack show exceptions and use the common logger and then run this app that we defined up here. And what that'll do is anytime a request comes in from the web server will cook the environment, which is all the CGI headers, and call this proc and pass that in, and we're allowed to do whatever we want with that. So Merb is entirely built on rack, and we have a number of middlewares we use, one for like cross-site request forgery protection, another one to ensure content type, another one for a debugger, and for a profiler, and for a number of things. So you can build up these middlewares and stack them together to build an application chain. It's really powerful. We're at Google here. I know you guys use Django a lot. And Django has a concept called apps, which is little slices of an application, like a little blog or a little forum or a little wiki. And you can stack multiple of these together to create a big application. And we copied that in something called Merb slices. And these are basically full-blown Merb apps, but self-contained in a Ruby gem. And then you have a main Merb application, and you can say, OK, I want the authentication slice, and I want the forum slice, and I want the wiki slice. And then you build your main application up in your app, and you can override any controller or view or model from the slices up in your application. So this gives you a way to share code reuse and to share functionality between applications very easily by using the Ruby Standard Package Manager to ship these slices, and then assembling them together into a cohesive whole. So I get this question asked a lot: why didn't you just work on Rails and do all this kind of stuff? Why did you fork the community? All this kind of stuff. And I think that monoculture is bad, and the more choice there is for people, the better off we are. So I think a lot of people have kind of been down on me about Merb and not just doing it with Rails, but I'm a big supporter of both frameworks, and I think that there's stuff that Rails is better at and there's stuff that Merb is better at, and we see a lot of people actually using them both together in conjunction. People are doing their heavy JavaScript UI stuff with Rails and then doing their back-end web services and heavy lifting with Merb and combining the two, and I think that's really powerful. And everyone wins when there's some competition, right? If Merb and Rails are in a performance competition, the users are the ones who win. And there's just, if there's only one framework that everybody uses in Ruby, then those guys don't have any reason to not rest on their laurels, right? They are it. And with Merb kind of in the rearview mirror a little bit, I think it's been improving both frameworks a lot. So, and lots of Merb's lessons can be applied back to Rails. I've actually contributed a bunch of the rack machinery back to Rails, so now Rails can fully run on rack, and a number of other things. We wrote a better inflector that changes, singular to plural back to singular for different inflections. And we wrote one that was 10 times faster, and we contributed that back to Rails. So there's a number of stuff that's being spiked and experimented with in Merb, and then gets applied back to Rails so everybody can benefit. So that's the reason for Merb. Just going to kind of keep moving quickly here, talk a little bit about Rubinius. 1 second. So Rubinius is a new environment for running Ruby codes. Max's Ruby interpreter, or MRI, is what they call the standard Ruby runtime. And the standard Ruby runtime had no specification. So there's no specification for the Ruby language. There's just, here's what the interpreter does. And if you want to write an alternate implementation, you need to reverse engineer it, pretty much. So Rubinius basically has reverse engineered Ruby 1.8.6. We've written a new virtual machine in C++ for running the actual bytecode, and then we've written a kernel, a Ruby core kernel. So we have things like string and hash and array are all written in pure Ruby. So it follows it's loosely based on the SmallTalk 80 Blue Book, which is a classic virtual machine book for building SmallTalk VMs. And Evan has taken a lot from that. We use a lot of the same classes and a lot of the same optimizations and apply it to Ruby. And the kind of end game is to have as much as possible of Ruby be in Ruby, so kind of turtles all the way down. And this gives us much better introspection into the runtime of the language. We can, almost any object that's in the VM is also exposed as a Ruby object, so that we can inspect the bytecode of a method or a number of other things. There's going to be all kinds of cool new tools people are going to be able to build along the lines of refactoring browsers and different code completion tools and stuff, because you'll have much better introspection into the Ruby language itself. Right now, current Ruby is mostly written in C, and it's in a fairly opaque kind of style, And it's a fairly complex project. And so there's all these kind of edge cases of the language where you feel like you're in Ruby, but it's actually dropping into C behind the scenes. So there's some things that are unoverridable, and there's a little impedance mismatch there. So trying to get as much of the system up into Ruby as possible has been offers some really nice advantages. We also have a library called Subtend that is a interface for running C extensions that are built for Matz's Ruby. There's a lot of, Ruby's not the fastest language around, so there's lots of C extensions people use in production, things like ImageMagick or full text indexing things, or sometimes people drop down and write C extensions for performance critical sections of computations of their application. So we felt it was fairly important to be able to support those. So we've written a layer that allows you to just recompile a C extension built for Matz's Ruby and run it on top of Rubinius. So that'll help ease the transition. For VM nerds, we've got an accurate generational two-stage garbage collector, whereas current Ruby has a very conservative mark and sweep garbage collector. And one of the big issues with Ruby's garbage collector is that it actually sets the mark bit for each object in the object itself. So if you, say, want to spawn a process and load all of your Ruby code and then fork children and count on Linux's copy on write to save memory, you're going to be disappointed because you'll fork these children, and as soon as the garbage collector runs in the child, it'll walk the entire object space and mark every single object, so the kernel will see that and say, oh, you no longer copy on write, you need to copy all this memory over. So you'll end up with two full-size processes rather than one big one and one little one. And that's a major disappointment for trying to run a high-volume Ruby web app, because you basically pay the full price for loading everything into memory for every process. And it's also the garbage collector is very conservative. Anything that's on the heap that might look sort of like an object will not be collected. So Ruby has some major memory problems. Once you use memory, it never gets released back to the OS, and it allocates it in 8 megabyte chunks. So that's why the processes get so big. They keep, basically the biggest amount of memory you've ever allocated for the life of the process is the size the process is going to stay. And that's no fun when you want to do like an image manipulation that loads a whole bitmap into memory, but then you ditch it later, your process is not going to get smaller again. So people end up using something like monet or some kind of watchdog process to like watch the process and say, hey, if you go over this much memory, restart it. And that's pretty gross for production systems. So having an accurate generational collector is a huge advantage. Very similar collector to what Java uses. Bytecode-based virtual machine. So Rubinius compiles to a Rubinius bytecode set. And we've got some cool stuff like Rubinius archive files, which are basically similar to Java jars or wars, where you can compile your whole application, all the bytecode into one file, and then ship one file for deployment. So that's a nice side effect of having a bytecode virtual machine. And it's capable of bootstrapping itself. It actually, the compiler and the parser are written in Ruby, and Rubinius is actually bootstrapped off of Matz's Ruby, using it to compile itself, and then going from there to move on to everything. So taking a lot of stuff from SmallTalk in Rubinius. It's basically the SmallTalk 80 Blue Book, like I mentioned, underneath, but we've got Ruby syntax, Ruby behavior, and all the guys on the team have been researching all kinds of crazy papers that they can find for different optimizations. They've actually got LLVM wired into the back end of the VM now for taking the Rubinius bytecode, doing a translation to get LLVM bitcode out of that, and then using LLVM optimization passes and compiling to native machine code. So there's a lot of headroom for making this thing really fast. Current state, they decided to rewrite the VM in C++ back in May, because the whole project is test-driven, all the Ruby components at least, but the VM was written in C, wasn't very heavily tested, and it was starting to kind of outgrow itself and become too complex to maintain. So, Rubinius was capable of running Rails, which is like the big test for any new Ruby virtual machine at RailsConf in May. And it's kind of gone off the map a little bit because they were like, hey, we run Rails, now let's rewrite the virtual machine in C++. And so that was, a few months of no apparent progress, but they're making really good progress on that. They're running about 80% of the spec suite again, and they're going to merge that back into head here shortly. And we're really hopefully looking at within 6 months having production ready Rubinius 1.0 that's faster than Matz's Ruby. And I think that'll be a happy time for lots of people. So there's a division of Ruby code. I'm going to get a little more technical here in Rubinius itself. So in kernel, we have our own kernel, which is basically how Ruby is defined. And all of this stuff is written in C in the standard Ruby. But if you download the Rubinius project, you can actually read through all the different stuff in kernel. And the VM actually loads all the stuff in kernel directly without any requires. We've got one file that kind of tells the kernel what order things have to be loaded in. And then we've got a bootstrap, a platform, and a kernel. And Bootstrap is real Rubinius specific. It's basically light Ruby classes that wrap around calls into the VM with Rubinius primitives. And that's specific entirely to Rubinius. But then we've got Platform, which basically uses our FFI to tell which platform it's on, BSD or Mac or Linux or whatever, and set all the right environment variables and set all the right calls into native code. And then we've got the kernel, which is no Rubinius specific primitives are in there. It's all just straight Ruby code. And maglev is another Ruby VM by the Gemstone SmallTalk guys. And we've reorganized our kernel so that they can use our kernel. So we're going to be sharing that with them. And eventually, hopefully, JRuby is going to use our kernel as well once they can optimize the JRuby VM to run Ruby code fast enough to run everything in Ruby. So we're hoping a big goal of the Rubinius project is to have an executable specification of Ruby language, since there isn't one. So we've got a spec suite with like 40,000 executable assertions of what the Ruby language is. And we developed that by writing specs for Matz's Ruby behavior, running it on Matz's Ruby until it passes, and then checking those into the Rubinius tree and working on Rubinius till it passes these specs. So we're basically replicating bug for bug what Matz's Ruby does, because it is Ruby, right? And we don't want the Ruby language to fracture. And one of the really cool things is JRuby and IronRuby, which are Sun's and Microsoft's effort to build a Ruby VM, and maglev, are all sharing our specification suite. So they're all running our tests, so the Ruby language doesn't fracture. Everybody shares the same set of tests that says, this is Ruby. And we split the Ruby specs project off into its own site, and even Matz is going to be using the Ruby specs now, since they don't really have specs for Ruby itself. They've had a few disastrous releases where they made a public, here's the production release, and it doesn't even run Rails because they didn't have any tests to run. So we're hoping that having this nice executable spec for Ruby is going to help all the implementations be stronger. So userland, all the code is loaded by the kernel. It's not like an OS kernel. There's no real strict division between what can run in the kernel and what's in userland. And the different parts are labeled basically just to help developers talk about the code. Really big on first-class objects. Like everything, basically every part of the VM has a Ruby counterpart, so you can access all the different states of the VM, the compiled method, the method context, provides a huge amount of data in your Ruby code. And this is a really cool slide. Here's eval in Rubinius. And it's like 32 lines of Ruby, including comments and everything. And if you've ever written your own little scheme interpreter or any other kind of language, you'll know that eval is a really hard thing to write. So I think that's a pretty cool testament to how everything is in Ruby. Code as data, since the parser and the compiler are all written in Ruby, they're very flexible. And built in is the ability to take a string and turn it into an S expression, which is what the compiler takes and compiles into Ruby code. So you can see, 1 + 1 ends up being this S expression. And we're going to eventually have full macros, like runtime macros. You'll be able to say, okay, give me the S expression for this method. Now rewrite it and recompile it and reinstall it back as that method again. So it won't be quite as nice as Lisp macros because the syntax is so uniform, but it will get you most of the same power. So in Rubinius, like in Matz's Ruby, you define a method, and that, like the actual def statement, just returns nil. It doesn't return anything. So we've actually made the def statement returns the method context object for an actual method. So we can say meth equals def test, and then we can put meth decode, and we can get the actual bytecodes that this was compiled to that gets sent to the virtual machine for instructions. The parser is recently been completely rewritten in Ruby. And I don't know if anybody's ever looked at Ruby's eval-c or at Ruby's parser that's written in Yak, but it's one of the most insane parsers anywhere because Ruby, is real big on making the language look as beautiful as possible, and that's at the sacrifice of the parser being as ugly as possible. So we've rewritten the parser in Ruby now, and so it's much more flexible and extensible. You can have parser plugins. So Ruby has a lot of stuff like, %R and then some brackets for a regex, or %S, these different little differentiators for doing different things. And you can actually, since the parser is pluggable, you can write your own and say %U or whatever and do your own kind of things like that. So it's pretty cool to have the whole parser and compiler toolchain be in Ruby. It allows for a lot more flexibility with experimentation. Like, I want to add this feature to the Ruby language. If you're going with the normal Ruby, now you're deep in crazy C land, whereas with this, you're still in Ruby. The compiler is all in Ruby as well. So the parser takes the raw source code, converts that into a sexp, and then feeds the sexp to the compiler. The compiler transforms that into the AST. That gets walked and turned into the bytecode, and then fed into the virtual machine, or stored on disk or whatever. And since the compiler is all in Ruby, you can write plugins for it very easily. So say we want to add a plugin for something called method, which will return the current method context for whatever method you're in. We write this simple plugin. G is the bytecode emitter. We just do a couple things here. If the call method equals method, we're going to push our context and send this method thing, right? So what this ends up doing is rewriting method when you see it into method context current method, which would be like this. Defblah method.name will give us a symbol of that method. So it gives you very deep introspection in the language and really easy ways to hook into the compiler to add custom stuff you may have not considered in Ruby itself yet. A block environment is basically an object we create that contains the environment and the code for a block. And block environment call creates a block context and activates the block. So if we say defblah and we assign block given, we'll get the block object and call blah puts hello. We can say decode that method and give us the literals and the bytecode for it, tell us where the home was, where the receiver, all this kind of fun stuff. So as you can see, there's no way to get this kind of information from standard Ruby. So this is going to open up, I think, a lot of different tooling and IDE support that is just not possible yet. Send sites. These are like call sites. This is kind of where we base our polymorphic inline caches on. Every place where a call is performed, where there's a sender and a receiver and a method is called, we create a send site object. And every time a method is called in that same certain way, we increment a counter on it so we can track how many times a call is, and we can use that information later to recompile and inline methods for dynamic optimizations. It also allows us to put in different caching and different method lookups. Like the standard slow lookup in Ruby has to, okay, I'm in this object. Does this object have these methods? No. Okay, go up the included module chain and see if it has the methods, then go up to the superclass, and then go all the way up to objects. So it's like chaining through all these objects, doing a hash table lookup in each one, which is fairly expensive. With send sites, we can actually, if we see that a certain method is getting called most times with a certain kind of receiver, like it's a fixed num or the argument's a fixed num, we can compile a native method, which is basically just raw machine code that does the same thing, and install it in that send site so that instead of having to do the slow method lookup, Ruby can just say, okay, I'm coming at this send site with this sender and this receiver. Okay, I can just execute this native code rather than doing a lookup. So it gives us a lot of power for optimization. So if you look here, we're defining a method. And then you can see the method literals 0 is a send site. And when you hit it, you'll see that there's one hit. You hit it again, you'll see there's 2 hits. So it's available even in Ruby code. So a lot of these optimizations we do as far as recompiling and adding native methods, the code is actually in Ruby to do that, not in C. So we can see who the receiver was, who the sender, the compiled method was, and the selector, which tells it whether to go look in native code or whether to do a slow lookup. Extensions, building an API compatible layer, which is sub 10, and this is just for running standard Ruby C extensions with just a recompile. So it's pretty cool because none of the other new VMs run any C extensions, and a lot of production Ruby code has at least 1 or 2 C extensions. So Rubinius is going to be the only alternate VM where you'll be able to run your code unmodified. So that's pretty powerful. The issue, though, is that in order to completely emulate the standard Ruby C interface, we have to do quite a bit of copying of data and isolating the pointers and all this kind of stuff and hooking in with our own garbage collector. So doing it this way is kind of a second-class citizen because it's quite a bit slower, but it will still work, which is nice. Rubinius also has a true FFI, foreign function interface layer, that's pretty sweet. This is part of our POSIX platform, which runs, hooks into the POSIX system, whatever it is based on your environment, BSD or Linux or OS X. And you can see here, we're just writing straight Ruby code to say we want to get our malloc and realloc and free and rand and all this stuff just from the POSIX platform itself. And this code, we tell it what the types are, return types and all that kind of stuff. And so this is like the native method, right? FFI set errno is what the call is in the C standard library. This is what we want it to look like in Ruby, errno equals, and it takes an int and it returns a void. And so describing this in Ruby, the FFI layer will go and it uses GNU Lightning, which is a native machine code generator, and it will automatically generate the wrapper and allow you to tie into native C code without having to write any C code to do the wrapping. So going forward, you can just recompile your native Ruby extensions and have them run on Rubinius, but if you want high performance, you can just write Ruby code without changing your C code at all to call into C code. So it's a pretty sweet way of doing FFI, and we've got like a MySQL adapter and a number of other things written in this FFI style. Multi-VM and concurrency support is one of the big issues. Ruby itself uses green threads, which means the whole interpreter runs on one operating system native thread, and then it has its own scheduler and switches between the green threads within a process. So there's no multi-core for a single process in native Ruby. Rubinius supports multi-VMs in the same process. Since the whole VM is written in a thread-safe manner and it's reentrant, we can actually spin up multiple VMs in a single process. Each VM runs on its own native thread, so you can use multiple CPUs, and then each VM runs any number of green threads inside of it. So you get this kind of M times N concurrency going on. And there's a simple way to communicate between VMs, like from your Ruby code. I could say, here's my args, spawn a new VM with these arguments, and do a standard out gets on it. And it's just like I was spawning a new Ruby VM from the command line or whatever. And then in the other file I loaded, you can say Rubinius VM each message, and I get the messages. And you can pass just primitive messages between VMs like ints and symbols and strings and simple arrays. I think that's about it, maybe hashes. But it's a real nice way to take advantage of multiple CPU cores, and it's going to play a big factor in a Rubinius application server we're building to run Rails and Merb apps and stuff. So you can see, let's say here, in this file, we're going to watch for each message, and we're going to exit if we get the exit symbol. Otherwise, we're just going to put out the message. And here, we're going to say, Rubinius spawn that other file, and pass in these arguments, and get the standard out. And we'll see we get those. And if we pass in exit, you'll see that goodbye, and the other VM is joined and left the picture. So it's a pretty nice way of working with multiple CPUs in the same process without having to change a lot of your Ruby code. You can just run standard Ruby code in each VM and have them pass messages between each other. We've also got, so threading a little bit, we'll talk about. In standard Ruby, we're basically the same as standard Ruby. We've got green threads, so they task switch between each other. Simple timer based in for preemption. The API is exactly the same. The VM itself is built on libevent, which is an event-driven I/O multiplexing system. So our I/O subsystem is far superior to standard Ruby, which has some problems. All I/O is non-blocking, and everything is based on this libevent loop. So within that loop, we use something called a channel to provide scheduler notifications to schedule these green threads. And we use something called a task, which is from the Pi calculus, for building our thread abstraction on top of. We also have built-in actors, similar to Erlang, which an actor is a way of doing concurrency where you have a lightweight process or whatever called an actor that has a mailbox, and you send messages to it, and it can selectively pull messages out of the mailbox, execute code, and send messages back to another actor. So Rubinius actors work basically really similar to Erlang actors. They're not quite as inexpensive to create. I think in Erlang it's only like 360 bytes for an actor, where in Rubinius I think it's more like 1.2 kilobytes or something, but it's still more efficient than threads. And it's basically a lot similar to Erlang. Like if we say, okay, let's just make an object called data, which is a struct with a value, and we'll say we're going to spin 10 actors, and the master actor is actor current. Then we can loop over those, spawn an actor, passing in the master, and then do a receive, just like you would do in Erlang with a filter, and we'll say filter when data. So when an object that gets put to this actor's mailbox is an instance of data, then we'll accept that message and we'll send the value back to the master. So you can kind of see this is just a simple example. Loop over each actor and send a data with a number in it, and then grab the actors from receive, and then say that the values are the same. So it's a nicer way than threads in my mind to organize concurrently communicating processes. And you can actually use the Rubinius actors across multiple VMs. It's transparent. The actors can spread out across all the VMs you have running. So you get a native thread per VM, and then you get a number of green thread switch actors on each VM. Channels are what provide our basic building block for concurrency in Rubinius. It's basically a thread-safe channel that you can send a primitive over, like an int or a symbol, and it's a way to block waiting for some kind of message between threads. They're simple. They provide a nice interface to the outside world. So we can say, okay, let's make a new channel. Ran is false. We'll spawn a thread, and we'll call cReceive, and that will basically block this thread waiting on something to be received on this channel. And then we'll say ran equals true after this returns. And then we'll run the thread. We can see that it has not ran yet. And then if we push a symbol into that channel, you'll see that it will wake up the thread here at thread receive and continue on with its game. So that's the basic building block of concurrency in Rubinius. It's used for timing as well with scheduler in the VM. So we can say, here's a new channel. We want to do something in 5 seconds, and here's what we're going to send on the channel. And we'll say scheduler, send in seconds, this channel in 5 seconds, and the symbol did it. And then we can say, the time now is this, right? And we'll say cReceive, and that will block until it did it on the channel, and the scheduler sends that, and then we can see, here it is, 5 seconds later, we receive that block. So it gives us basic building blocks for building timing and concurrency. It's also used for all the I/O events and can be fired based on Unix signals, so it's used for the full I/O subsystem and all the forking and managing of processes and stuff as well as event-based interface to wait. So there's no blocking I/O in Rubinius at all. It's all non-blocking, and we use channels on top of that to simulate blocking. So Ruby specs, I already mentioned this a little bit. There's a website if you want to help out or go check it out. All of the major implementations are using this spec suite now, which I think is one of the sweetest things to come out of the Rubinius project, is the fact that it's going to help Ruby not fracture as all these other implementations build Ruby, because now they have something they can run to verify that they are in fact Ruby. Whereas without that, I think we'd see major schisms between all these different platforms. So I'm really happy that everybody has kind of picked up on this spec suite, including the Ruby core guys. Mats has given it its blessing and everything. So I think that's huge, because Ruby does not have any kind of specs. There's like maybe 20 tests that come with the project when you run make tests, and they don't really test much. So there's been a lot of kind of bad releases of Ruby because of that, because there's no way for them to verify that what they've just done change-wise still lives up to the spec, because the only spec is like run it and see if it runs, right? So now with the specification suite, we can test releases before they come out and verify that they're still passing all these specs, and I think that's a huge advantage. Yeah, I'll open it up for questions now and see if people have any questions.
Just a quick one. The specs, out of curiosity, what are they implemented using?
Our spec,
Yeah.
except for it's actually called M spec, because Rubinius couldn't run our spec, for the longest time because RSpec's fairly complex. So MSpec is basically RSpec compatible. It can run the same RSpec syntax tests, but it has a bunch of stuff built into it for saying, okay, this only runs on MRI, this one can run on JRuby, but not maglev or whatever. So it gives the implementers a nice way to say, we're not feature compliant on this one yet, but so yeah, but it is RSpec syntax. Yeah.
So you mentioned you didn't want to fracture Ruby code, but I mean there are new features, method context and so on that.
Yep.
There are going to be new code that depends on that, as well as to a minor extent namespace conflicts. How do you envision the code bases living?
So I think that there's going to be, each new implementation is going to have certain features that other implementations don't. And so I think people are going to need to get used to organizing their code in a way that says, this is my Ruby code, right? And then I have this file for when I run on Rubinius or this file for when I run on JRuby. And it's just, you don't want to fracture the language, but there are some things that can be done that are very interesting that can't be done on other VMs. So it's a good question. I'm not sure exactly how that's going to play out, right? But I think that we'll have some, by the time we're getting 1.0 out the door, we'll have some thoughts on that, on how to organize your code to not get tied to a certain platform. And we've also done a number of things, like Merb uses a number of extensions to get like the arity and the arguments and defaults of a method. And that we wrote a C extension so we could do that on MRI, but then we thought, well, we need this to run on all the platforms. So we were able to just write Ruby code to get it to work on Rubinius. We were able to go to JRuby and have them implement it in Java, and we're able to keep the same API across things. And JRuby is using Rubinius's API for the multiple VM stuff they're working on, so it'll be the same API to spawn multiple VMs. And as much as possible, when there's a feature that may not exist in Max's Ruby, but may exist in these other implementations, we're trying to keep it the same across them. So there is going to be some schism as people use these new platforms, but we're trying to keep it as minimal as possible. Okay, thanks a lot.
Okay, thank you, Ezra.
Yeah.